Hello guys, welcome to Last Hour Mathematics. Today I'll be teaching you coplanar forces. Kindly watch all the videos in sequence so you can follow appropriately. If you've been following me, we have treated parallelogram law of vectors, and we said parallelogram law of vectors is only used when we have only two forces and we are required to find a resultant force. We moved on to the Lami's theorem, where we said we'll be given three forces in equilibrium to find an unknown force, not a resultant force. And today we are moving on to another concept we call coplanar forces, where the forces are more than two, unlike the parallelogram law of vectors formula that we learned. Now we are considering forces which are more than two, and we need to use a different theorem. And today the theorem we are going to use for multiple forces, that's forces more than two, is the concept of the coplanar forces. But it also has limitations, so you can see all the theorems have their own limitations. Coplanar forces are used for forces more than two, but only for forces in the same plane. What do I mean by that? So when you want to find the resultant of more than two forces and you want to use the concept of coplanar forces, then those forces you are considering should all be in the same plane. Here, assuming we have a z-axis, a y-axis, and an x-axis. Between this x and this y, we have a certain plane here. Between this z and this x, we have another plane. Between this z and this y, we have another plane here. What I'm trying to say is that when you want to use the concept of coplanar forces, then all the forces in consideration must be in the same plane, and they can be used to find the resultant of forces more than two, unlike the parallelogram law of vectors formula we use for only two forces. So I could have all the forces only in the same plane, so all the forces will act in this plane, or in this plane, or in that plane. So don't worry yourself much. In your syllabus, most of the questions come in a single plane, and you'll be using the x and y plane. I just want to clarify this. But if you want to go forward in mechanics, advance in mechanics, there's a general rule called the pure resolution approach. That's the last approach I'll be teaching. This is the most versatile approach in finding the resultant of a force. But these ones are a bit restricted, but they are in your syllabus, and that's what you need to know now. Okay, let's get going. So typically, let me put this here for the meantime. Typically, you'll be given forces acting in different planes. That's for acting in the same plane, for coplanar forces. So you have y-axis here, x-axis here. So you see, I've just taken one plane only. So you might have a force acting here, F1, inclined at an angle theta here, or you can put your angle here. You might have another force here, say F2, inclined at an angle, let's say alpha. To the horizontal, you could have another force here, inclined at an angle, say gamma. You could have another force here, inclined at an angle here, say delta. Okay, so this is how you'll be having your questions for coplanar forces. But we want to learn a certain concept here. Coplanar forces uses the magnitude direction approach. Okay, so most at times you'll be given the question in magnitude direction format. If they don't give you the question in magnitude direction format, they will sketch this on the question for you. Okay, and that is what I taught in my first video. on how to represent vectors in magnitude and direction format. So normally the coplanar forces will come this way or they will come that way. They'll either draw it for you or you'll be asked to draw it based on the values they give you in your question. But our main concern here is how do we find the resultant force? To find the resultant force using a coplanar approach, what you need to do is to first sketch what you have in your question and find the x and y components in relation to the y-axis only or the x-axis only. What do I mean by that? Assuming I wanted the x and y component for this force, because I need a component to find my resultant. I need a component of this, component of that, component of this, component of that. I add everything to get my resultant force. So I need components. If I wanted to use the coplanar approach and I wanted components here, what I have to do is to find the x component here and the y component here. So if I wanted the x component here, I'll use opposites and hypotenuse. Okay? So what will I have? That's sine. So I have sine of theta being equal to x on f1, which means x equals f1 sine theta. So this is my x component. And my y component will be this opposite, so this will be my adjacent side and this will be my hypotenuse. So I can say cos of theta equals adjacent, which is y, over hypotenuse, which is f1. So my y equals f1 cos what? Theta. So for my first force f1 in component form, I'm having my x component f1 sine theta and f1 cos theta. What if I try to resolve rather here? Thus, I didn't resolve with respect to the vertical axis with this angle, but I wanted to use another angle here. Say beta. I cancel because I also have alpha here. Say beta. So if I wanted to use beta, things are getting a bit rough here. So this is f1, this is beta. So I have my y here, have my x here. So if I wanted this x, this is my opposite, this is my adjacent. So I would have said that a cos of beta is equal to my adjacent side over my hypotenuse f1, which makes my x component f1 cos of beta. If I wanted my y, I would have used opposite and hypotenuse. So I would have said sine of beta equals opposite on hypotenuse f1, which makes my y component f1 sine of beta. Okay? So I'll have my f1 component being equal to f1 cos beta, f1 sine of beta. So you see, depending on where you resolve your components, you either be having an x component in terms of sine or in terms of cos, and the y component in terms of cos or in terms of sine. So it's either you resolve all these forces with respect to the vertical, that's with respect to the y-axis, or resolve all the forces with respect to the x-axis. This is a bit different from the resolution I showed you initially in my first video, resolution of forces. That's under pure resolution. This is coplanar forces approach. So what we want to learn here is that to make things simple for you, anytime you want to resolve components in a coplanar form, take one axis of reference. If you decide to resolve all your forces with respect to the y-axis, then use this formula. If you decide to resolve all your forces with respect to the x-axis, then use this formula. Never mix them. Use only one axis. So when I come to the force F4, I take my angle from here to there. If I wanted to use what? My y-axis, then my angle here will be what? 90 plus delta. But then because I took my angle with respect to the y-axis, I'll be using F4 sine, that's 90 plus delta, then F4 cos 90 plus delta. I do the same thing for F2. Start from here all the way here and use this formula. But if I wanted to use the x-axis as my reference, then respect to this, I take my angle in this direction to where the force is. When I come here, I take my angle this way. When I come here, I take my angle from here to here. When I come here, I take my angle from here, and I'll use this formula. Okay, so this is a very simple theory, and it's in fact one of the most simplest theories in finding the resultant of a force when you are using only forces in the same plane. Okay, so let's try and see what we can do with the question that we have, then we proceed to see more examples. Okay, so join me, let's go. Okay, so let's solve this question. First, let's sketch quickly. So have my x and y, I have my 30 Newton force, and these angles are measured from the North Pole. So I have from here 30 degrees. This is my North Pole. 30 degrees. I have my 30 Newton force here. My second force is 5 newtons at 180 degrees. So I have my 5 newtons at 180. So my 5 newtons will be here at 180 degrees. Then that's from here all the way here. Then my 240. Okay, that will be from here up to here is what? 180. So 180, how much are we left to get to 240? That's what? 180. That's 240 minus 180. 60. So it means from here to here is 180. When I add 60 to it, I get this 240 here. Are you following me? Okay, because from here to here is 180. This side is 270. So 180 plus 60 gives me 240. We are on the same page. So let's go. This is my F3 force, and it is 12 newtons. This is 5 newtons. So we want to use the coplanar approach, but first we need to choose what axis we want to resolve from. So let us use the first method. Let us resolve with respect to the y-axis. It means I need to use the formula f sine theta, f cos theta, where this theta is measured from where? The North Pole. Or let me say the y-axis. I prefer you say the y-axis. Okay, so let's go. From the y-axis, I have my angle from here to here for the 30 newtons force. So it's 30. So I'll get 13 sine 30, 13 cos 30. My second force is 5 newtons. It will go from here all the way to the 5. That's 180. So I have what? 5 sine what? 180. 5 cos what? 180. Plus my third force, 12 newtons. So I have 12 sine the angle from here all the way here, which is what? 240. So this is my resultant force. So have 13 sine 30. That gives me 6.5. 13 cos 30. That gives me 11.25. 5 sine 180. That gives me 0. 5 cos 180. That gives me negative 5. Then 12 sine 240. 12 sine 240, that gives me negative 10.39. Then 12 cos 240, that gives me negative 6. So 12 sine 240, just cross-checking, negative 10.39, and 12 cos 240. That's negative. So we are okay. So now let's add all the x components, add all the y components. So I have 6.5 plus 0 plus and negative 10.39, giving me negative 3.89. So I have 11.25 plus negative 5 plus negative 6. This gives me 0.25. Okay, so my resultant will be the square of this plus the square of that, all in the square root. So my R will be equal to the root into bracket negative 3.89 all squared plus 0.25 all squared. Can you see? So the resultant is 3.89 newtons. So one decimal place, you have R equals 4 newtons. So this is my resultant using the coplanar approach. Now, let us resolve everything with respect to the y-axis and see what we also get. We are supposed to get the same answer. So, let's see, this is what we have. So this is what we have for the x-axis approach. I have my diagram. So we quote our formula. We are going to get f cos theta, f sine of theta. Now, there's something about trigonometry. Now that we are taking our angles with respect to the x-axis, remember, when we're taking respect to the y-axis, we took it from the y to the vector or to the force. So now we take it from x to the force. But in trigonometry, when you go in an anti-clockwise fashion, okay, the angles are positive. But when you go in a clockwise fashion, the angles are negative. Please take note. Remember, we are moving from this x in an anti-clockwise manner to the force. So because we are moving this way, okay, the angle here is 60. Because we are moving this way, our angle is going to be positive. So I'm going to have 13 cos 60, 13 sine 60, plus, let's go to my 5, okay, my 5. So what do I have for my 5? What I have for my 5 is, I have a 5, okay, cos the angle from here all the way to here, which is 90. But because it's clockwise, it's supposed to be negative. So I have 5 cos negative 90, then 5 sine negative 90, plus my third force, 12 newtons. So I have 12 moving from here, this x all the way here, which is 90, plus 60 giving us what, 150? 150, okay? So I have 12 cos negative of 150, 12 sine the negative of 150. Okay, so my R is, so 13 cos 60, what do I get? 6.5, 13 sine 60, what do I get? 11.25, 5 cos negative 90, 5 cos negative 90, 0, 5 sine negative 90, negative 5, 12 cos negative 150, negative 10.39, 12 sine negative 150, negative 6. Okay, so let's add all our x, add all our y. So you can see it's identical to the y. It's the same thing actually. So we have 6.5 plus negative 10.39, negative 3.89, then 11.25 minus 5 minus 6, 0.25. So my resultant is the root of negative 3.89 squared plus 0.25 squared. So my R is the root into bracket negative 3.89 squared plus 0.25 squared. This gives me 3.89 and R is approximately 4 newtons. So we are getting the same answer, okay? We are getting the same answer as resolving on the X and the Y. Now let's go to our resultant. This is our resultant force, but we are left with our direction, okay? Remember, we need our direction. So remember, for direction, you can't state your angle respect to the x-axis, just state it respect to the y-axis. So this is what we have for our resultant. We had what? We had our answers to be negative 3.89 and 0.25, but what I'm saying is, in finding the direction, so let's sketch so I can complete my statement. This is my y-axis, this is my x-axis. Now this is negative 3.89, which means we are on the negative axis, negative 3.89. Then positive 0.25, which will be somewhere here. This is not to scale, so I'm having my resultant somewhere here. Okay, so what I want to say is your direction is always measured from this y all the way here. So now we have R equals 4 newtons, but we are left with our direction. But measure this direction respect to the north pole only, the north pole only. This direction from here all the way here to the north pole only. That's what we need here. So this is what I'm going to do. I know from here all the way to this particular point is 270 degrees. So I'm left with this small angle here. This small angle here. Add it to 270 and I get my direction. So let's find that small angle using trigonometry. Okay, so assuming that angle here is alpha. On my x I have 3.89, on my y I have 0.25. So opposite on adjacent. So what can I say? My tan of alpha is opposite, which is 0.25, over adjacent, which is 3.89. Okay, so my alpha is the tan inverse of 0.25 over 3.89. So what is calculating? So I have shift tan 0.25 on 3.89. That gives me 3.677, blah blah blah. But remember, that's the angle here. We need the angle here plus 270 because we are taking a direction from the north pole all the way to where the force is. So what am I going to get? Answer plus what? 270. And what do I get? 273. 273. So my direction is 273.6. So to one decimal place is 274 degrees. So this is my resultant. So you know the coplanar force approach now is very simple, but it only applies to multiple forces in the same plane. Now we need a more general approach. Okay, approach. So if the force is not in the same plane, what do we do? This takes us to what we call pure resolution. Okay, let's get going. See me in my next video on pure resolution. Now we need a more general approach where we could find the resultant of our forces when multiple forces are not acting in the same plane, and this takes us to pure resolution.